Algebra 1, Lesson 41, we are looking at finding rates of change and slope. So being able to look at a line and say, how fast is it rising or falling? So we have a couple vocabulary terms. Rate of change. It's really just a ratio that compares the change in one quantity to the change in another. So we're looking at the change in the between the dependent and independent variables. Slope is the rate of change. Really, it's just another word for it, which is the ratio of the rise over the run on a graph. So one way to remember slope can be thought of as the slope of a hill, how steep it is to go up it, and how much energy you would have to put in to go up that hill. It would change based on how high the slope is. So looking at this graph, we want to say, what is the rate of change for this graph? And we say, from this point to this point, what is the rise over the run? Well, we can say that we are going up 2 and over 3. So we would say that the slope of this line is 3 over 2. Or, sorry, let me say that again. We're going up 2, so our rise is 2. So 2/3 is the slope of the line. Okay. So, let me just put this back. Or not. We have a couple different types of lines. Now, we actually have 4 different types. 2 of them are here. We can say that a line is increasing, so the slope is positive. How we know it's increasing is from left to right. Just like we read a book, we're going to read a line. So from left to right, we say that it's going up, so we say it's increasing. And left to right, if it's going down, we say it's decreasing. Its slope is negative. These are 2 of our types. And so what about some other ones, like this? Find the slope of this horizontal line. Well, we know it's the ratio of the rise over the run. We say from this point to this point, there is no rise. There is no rise. So we would say our rise is 0. And we run 2. Well, 0 divided by 2, if I had 0 cookies and divided it to 2 people, I would still have 0 as my answer. So we have a horizontal line with a slope of 0. How about this vertical line? Well, from point to point, we are rising 2, but we run nothing, which when we divide by 0, we call that being undefined. So a way to remember this is if I take 0 and divide by a number, how about k, that is okay to do that. Whereas if I take a number, n, and divide it by 0, that is not okay. Do not do that, no. Okay? So our vertical lines give us slopes that are undefined. And if you remember back to our functions, remember that when we have our vertical lines, this is not a function. So another reason that this doesn't have a true slope, it is undefined. So if a line is horizontal, the slope is 0. If a line is vertical, the slope is undefined. Now let's try a couple in the thought of rate of change. So we are going to look at the change in the dependent variable over the change in the independent variable. And we use delta to represent this. So another way you might see it is delta of, so change of the dependent over delta independent. And if we're going to think about this in our x and y's, really we're just saying the change in our y over the change in x, which really, the change in y, that's just the rise. And the change in x, that's just the run. Okay, so we're really just using the same idea as rise over run with our slope to figure out the change, the rate of change. So in this one, if we are using this table and we want to find the rate of change using day 5 and using day 2, we need to find the change in the dependent variable over the change in the independent. So we're going to start with our dependent variable, our y's, and so we're going to say, okay, well, from 75 to 120, I want to find that change, so I'm going to find the difference between 120 and 75. And going in the same way, so 120 to 75, I'm going to do 5 minus 2 for the change in our x. 5 minus 2. So 120 minus 75, well, that gives me 45 over 3. Well, 45 divided by 3, that is 15. So what we are saying here is it is $15 per day. That would be our rate of change between day 5 and day 2. Okay, so we find our rate of change by doing that change of y over change in x. Now, what if you said, I actually found the change of 75 minus 120? I did that. Well, that's fine. 75 to 120, we just have to keep the same pattern and do 2 minus 5, which ends up getting us a negative 45 over a negative 3, which still ends up to be the same over here because we take a negative divided by a negative. Okay, let's try just a couple more examples. So Grace Adler is going scuba diving at t equals 0 seconds. She's at a depth of 6 feet. Okay, so I'm going to make a little table. So our time and our depth. So at 0 seconds, she is at a depth of 6 feet. So a depth underneath the water, so that's a negative 6. And at time 15, she's at a depth of 20 feet below the surface. What is Grace's average rate of change in depth? Well, I need to do the change in y over the change in x. So I'm going to do negative 20 minus, so the difference between those two, minus a negative 6 over 15 minus 0. So on the top, minusing a negative is adding, so we get a negative 14 over 15. Now, every rate of change, we're going to have some units. And in this case, we are talking about, well, the change in y, that's talking about feet. And our change in x, that's per second. Okay, so we have negative 14/15 feet per second. So almost a foot beneath the water per second. Let's look at another one. Will Truman is driving at t equals 4 seconds. He has moved 13 yards. Okay, so we have 4 seconds, and I'll just put yards here. And then we have 22 seconds, and he's 52 yards from his starting point. What is Will's rate of change in distance? Well, once again, we're going to do our change on our dependent over the change in the independent. So we get 52 minus 13 over 22 minus 4. I could have switched these. I would have just had to keep it consistent. So doing something like 13 minus 52 over 4 minus 22, keeping them in their positions. That's fine to do. It's just I like to work with positive numbers rather than negative, but that's my choice. Okay, I could have done this just the same. Okay, we get 39 over 18. I can simplify that to 13 over 6, and, well, we're talking about yards per second. So we get 13/6 of a yard per second. All right, Karen Walker is in a plane getting ready to return to the airport. Starting at t equals 0 minutes, the plane is at 5,575 feet. At 15 minutes, the plane is now at 3,325 feet. So what is the average rate of change in altitude? Well, I'm going to put these, and I could put it in a table, that's fine. I'm going to put these in coordinate points. So at t equals 0, she is at 5,575. And at t equals 15, we are at 3,325. So I need to find the change in my y, so I'm going to do 3,325 minus 5,575 over, well, since I did 3,000 to 5,000, I'm going to do 15 minus 0. So I get 15 on the bottom, and let's see, I get a negative 2,250, which when I divide that, and remember it's negative because I have a smaller one minus a bigger one. When I divide that, I get a negative 150, and we are talking about feet per minute. So they go down in altitude 150 feet per minute. All right, just a couple more examples. All right, we now have this balloon at t equals 0 seconds. They're at 3 feet, and t equals 5 seconds, we're 18 feet. All right, so I'm going to do 18 minus 3 over 5 minus 0, which gives me 15 over 5, which is 3 feet per second. Okay, pretty easy one. And last example for this lesson. Anastasia is going bungee jumping, and at t equals 0 seconds, she is 350 feet from the river. After 4 seconds, she's now only 230 feet from the river. What is the rate of change? Well, I'm going to do 230 minus 350 over 4 minus 0. So we get 4 on the denominator, and in the numerator I get negative 120. So I simplify to get negative 30 feet per second. What that means is I am getting closer and closer to that river by 30 feet each second. Okay. You can take a second to look at this picture, finding positive slopes, zero slopes, undefined slopes, negative slopes. Okay. You can take some time to look at that. Well, I hope this was helpful for your homework and for studying.